On to problem 11, we want to know how many stereoisomers are possible for the following sugar. For that, we want to know our equation, which tells us the number of stereoisomers equal 2 to the n, where n equals the number of chiral centers. We should know that a chiral center is when a carbon is attached to 4 different things. First thing we should notice about this molecule is that the left and right side are actually about the same thing. So really, if we just have to do one of these rings to know what's going to go on with the other one. So let's look at our carbon here first. It's attached to an H. It's attached to this giant ring. And if we go this way, it's attached to an alcohol, another alcohol, and the third alcohol, and an ether. But if you go the opposite direction, we'll see an O first, which is part of this giant ether, and then the same thing, but since it's in opposite order, these count as two separate. So that will be our first chiral carbon. Let's look at this O. This O is not attached to 4 separate groups, so we don't have to worry about him. Now let's look at this carbon. To the right of it, we have the O attached to another carbon, OC. And then to the top of it, we have C attached to the OH, so that's a different group. To the left of it, we have a C first, then an OH, and then another C. So this is also going to be chiral since it's attached to 4 different groups. Okay, on to this carbon. It's attached to an H. Let's use a highlighter. So attached to an H, and to the right of it, we have a C attached to 2 separate groups. So that's going to be different than the one to the left of it, because this C is attached to an OH first, then another OH, so it's going to be different. Basically, if the ring's not completely the same or symmetrical left and right, it's going to give you 2 different groups. And then our last group is that OH at the bottom. Okay, so now we have 3 chiral centers. We'll go on to the next carbon. This carbon, same thing, it's hooked onto an alcohol, and to the right, if we go right and left, we'll have 2 separate groups, because if you go right, you'll hit a carbon, another carbon, then an alcohol, so 2 carbons, then an alcohol. If you go left, you go 2 carbons and an alcohol, but before you hit that second one, you'll have this group, and this side you'll have a ring, so they're still 2 different, they're not exactly the same. So this will also give you a chiral center. On to the next one, you have an H and OH. This side will go hit a carbon, then immediately hit this giant ring. If you go to the left, you'll have 2 OHs, and then all those different groups. So all of these are going to end up being chiral. And we already said that the one to the right is the same exact thing as this. So all of these are going to be chiral as well. And we can add those up. We'll end up with 10 chiral centers. So we plug that into our equation. So it's 2 to the 10th. Plug that into your calculator, you're going to end up with 1,024 as our answer.